Hello, everyone. In this lesson, we focus on the principle of color recognition. Image segmentation is one of the main problems in image processing, and its goal is to divide an image into multiple regions with similar attributes or features, which can be color, texture, shape, etc. Color extraction is an important link in image segmentation. It involves identifying and extracting specific color information from images, which is very important for subsequent image analysis and understanding. In this lesson, we start to learn about this technology. This lesson primarily covers the following points. By the end of this lesson, you are expected to achieve the following objectives. Before working on color extraction, you must first understand the color model. A color model, color space, is a mathematical model that uses a set of numerical values to describe colors. Common color models are RGB, HSV, HLS, etc. Here are introductions to two typical color models. 1. RGB color model. RGB color model is a color standard in the industry. Its model is shown in the figure. This color model obtains various colors by changing the three color channels of red, R, green, G, and blue, B, and superimposing them with each other. This standard includes almost all colors that human vision can perceive, and it is one of the most widely used color systems at present. The RGB color model is commonly used in color graphic display devices, such as color cathode ray tubes, color displays, etc. On the main diagonal of the cube in the figure, the intensity of each primary color is equal, and the equal RGB three-channel values are mixed to give different gray values, where 0, 0, 0 is black and 1, 1, 1 is white. The other 6 corner points of the cube are red, yellow, green, cyan, blue, and purple. 2. HSV color model. As shown in the figure, this model simulates how human visual cells feel about color. In the HSV color model, each color is represented by hue H, saturation S, and value V. The HSV model corresponds to a conical subset in a cylindrical coordinate system, and the top surface of the cone corresponds to the value V equals 1. It contains three faces R equals 1, G equals 1, and B equals 1 in the RGB model. And the color represented is the brightest. In the HSV color model, the color H is given by the rotation angle around the V-axis. Red corresponds to an angle of 0 degrees, green to 120 degrees, and blue to 240 degrees. Each color differs from its complementary color by 180 degrees. The saturation S takes a value from 0 to 1, so the radius of the top surface of the cone is 1. The three-dimensional representation of the HSV model evolved from the RGB cube. Imagine that you can see the hexagonal shape of the cube from the white vertex of RGB along the diagonal of the cube to the black vertex. The hexagonal boundary represents color, the horizontal axis represents purity, and the value is measured along the vertical axis. After understanding the color model, let's learn about channel separation. In the image color space, different components are stored in different channels. If we only need a certain component in the color space, for example, only the red channel in the RGB image needs to be processed, we can separate the red channel from the three channels of data before processing them. In this way, We can reduce the memory occupied by data and speed up the running speed of the program. Each color picture can be composed of 3 channels of RGB. RGB is the color representing the 3 channels of red, green, and blue. This standard includes almost all colors that human vision can perceive, and it is one of the most widely used color systems at present. The intensity values of the 3 colors of red R, green G, and blue B are all 0 to 255. So the 3 light can be mixed in each pixel to form 16,777,216 different colors. The 256 level RGB color is also abbreviated to 16 million colors, or tens of million colors, or 24-bit colors, 2 to the power of 24. In an RGB color image, the image is composed of 3 image components, each of which is its primary color image. When fed to an RGB monitor, these 3 images are mixed on a fluorescent screen to produce a composite color image. At present, the widely used expression methods of color information are based on the color matching equation of 3 primary colors mixed in proportion. The formula of the color matching equation is as follows, wherein C is any colored light, and A, B, and C are the weights of the 3 primary colors R, G, and B. Each pixel in a color T image can be represented by a vector A, B, C in a 3-dimensional color space, R, G, B. The proportional relationship of R, G, and B determines the chromaticity, hue, and saturation of the matched color light, and its numerical value determines the luminous flux of the matched color light. AR, BG, and CB respectively represent the luminous flux components of the 3 primary colors in color C, also called color components. When observing a colored object, it is often described in terms of hue, color saturation, and intensity. According to the 3 elements of naked eye color vision and hue, saturation, and intensity in his color model is proposed. In a given RGB color format image, according to each RGB pixel, you can get the hue component is as follows, wherein theta is as follows. The color saturation component is as follows. The intensity component is as follows. The above conversion formula assumes that the RGB value of the image is normalized to the 0, 1 interval, and the HSI result value is also in the interval 0, 1. 3. Color extraction tool in K-image software. Taking blue extraction as an example, add the image tool at 1 to the tool group at 2, change the name to blue square, and click on the image. Add the color extraction tool at 1 to the tool group at 2. Change the name to blue extraction. Refers to the output image of blue phone case at 3 the tool reference parameter. Select output mode as binary map at 4 and enter the RGB value range you want to extract at 5. Alright. Today we learned the fundamentals of image color extraction, the working principle of RGB and HSV color models, and the concept of channel separation. In the complex and changeable industrial environment, the object colors are differentiated, which requires users to flexibly set the variable parameters of color extraction in the software and reasonably set the range values in order to effectively extract colors. This lesson ends here. In the next lesson, we will use K-image software for practical operation. See you next time.